Alright, I have an iPhone 7 Plus here with a bad rear camera. The guy just said that all of a sudden one day it just stopped working. Said he didn't drop it or anything like that. I think he might have said he was using it or something. I don't know. Something just stopped working, and he brought it into a shop, and they replaced the rear camera in front of him, and it still did not work. They tried two different cameras. I was still very skeptical because it's usually just the rear camera. Okay, so he sent it to me. Looked like it was in really good shape. Not a whole lot. Yeah, looked like it was in really good shape. So I tried my known good camera and still nothing. I tried my known camera and I restored it to factory and still nothing. So the front camera works fine, and the front camera works fine. The rear camera doesn't work. The flash doesn't work either. And then if you go from the front camera to the rear camera and go to video, the flash is disabled. It's too hot. Signal comes up. So those are kind of all the symptoms that I encountered. So how do you troubleshoot something like this? Well, there's something called ZXW tools, which is vital for this kind of stuff. And if you go to, you can't really see here. I'll kind of bring it in a little bit, but if you go over to the left side here, you'll see. So this is the iPhone 7 Plus Qualcomm. Actually, this is the Intel, but the Intel version doesn't have the full schematic, so I just go to the Qualcomm version. If you click on connecting seat resistance, you'll see the red numbers here, which is the diode mode, and these are in millivolts. Okay, so I mean, first step of troubleshooting is trying a new camera. Second step would be to start diode moding all these connectors. Okay, and you know the values don't have to be exactly matching, but they should be fairly close to it. And the only ring, so all the rings checked out fine except for this one. Okay, this one said 500 millivolts, and I was getting 0.38 millivolts, or I'm sorry, 0.38 volts, 380 millivolts. So that's just a little bit lower than what it's supposed to be, and I checked my donor board, and the donor board said 0.48 volts. So definitely something is wrong. And if you click on the net button up here, you'll see all the points that it connects to. There's only one point on the front side, and looks like there's 2 points on the back side. Okay, so the fact that it just kind of died, and you know, this is a rear camera i2c line, so it is very possible that this could be the issue. And since there's only two other components back here, I mean, there's a resistor and a capacitor. So first thing I'm going to do is, I think you have to kind of assume that probably capacitors will probably blow, especially if it just kind of happened all of a sudden, you know. So I think what I'm going to do is I'm going to take this capacitor off here, and let's see if my diode mode comes back to me or not. Okay. So looking at ZXW tools, it is 2, 4, 6, and 7. So 6 is the resistor, 7 is the capacitor. So let's get to business here, and hopefully after I remove this capacitor, the diode mode will come right back to us. Okay. So let's see. So I'm really just gonna probably use my little pry tool here and see if I can just poke it off. I'm not gonna go too crazy with it or anything. And I guess you kind of want to be gentle with this Wi-Fi chip, because you never really want to overheat that mother. Bad news bears if you do that. So I'm going to do a gentle heat right here, and oh man, it's all covered up. Gosh. Okay. It's a gentle heat, and I've already found my point here. I'm going to scrape this epoxy off and then take this capacitor off 2, 4, 6, 7. Okay, so this guy right here. So just very gentle heat to remove the epoxy. You don't want to expose the ground plane below, so don't dig too deep. And you could also probably just use your hot tweezers and just kind of pry it up. You don't really want to tear any pads, although this capacitor is not really probably that important, unless it's shorted. But it's there for a reason, so we should probably put it back. Okay, so I'm just going to use my other tweezers so I can kind of grab at it a little bit. I don't know if this is the problem or not, but I will know shortly. Nice gentle heat. Don't really want to rip any pads. I could probably use some Dumonts at this point, right? This thing is so tiny. Probably don't even really want to do much to it, you know. Yeah, okay, that's gone. Well, I won't even be able to test it, but what I could do is just probably just do diode mode, so I can just test this point right here. And I am at 0.33. 2, 4, 6. 0.34. 0.34. So let's find out what's going on here. So what's on the other side of this? So this is the I2c clock line. So I think maybe, and where does this lead? Where does the I2c clock line lead? So let's click on net. I'm assuming this probably leads to the CPU, which is not good. Okay, so it leads to the M2600, which is and then it leads to this guy. And then it leads to the CPU. Okay. So I guess it could be this as well. Well, yeah, it could be this as well. So let me just double check again, and then if that is bad, then I'm gonna have to start searching maybe those two resistors. Maybe one of them is bad or something like that. So let's try this one more time. .36. It should be 0.5 something. So that's not good. So let's just go to our donor board real quick and let's just test that real quick, just to make sure that we're supposed to get the right thing. Two, 4, 6. Reverse die leads. Okay, let's just do it like this. How about that? That's a little bit easier. Okay. 2, 4, 6. 0.472. Okay, something is just not right. Something's just not right. With that line, something is just not right. So, I guess maybe, let's see, what do we do now? Since it's not the capacitor, let's go back to the front side maybe, and let's take a look at this resistor here, which, I guess, is it possible that maybe if one of the resistors was bad? So this is PP1B8. Okay, I guess maybe we should just measure PP1B8 to see what we're getting there. But that's just the main power line, so that should be okay. You know what though? Let's see. I feel like I've already gotten. Okay, so I've already taken this off, and because I played with it a little bit earlier, and it is going to be the third one. Third one. Okay. So this third one right here, which I feel like I've already. So 0.36. I feel like I've already replaced this one actually, because it looked like it was not good earlier. But I also feel like I have, yeah, I definitely replaced that. Is there anything else it could be connected to? Yes, I definitely replaced that for a reason, but let's measure this. .74. Oh well. .74 with the resistor off. Okay, so maybe we should just take this resistor off real quick and then see what we get from there. Since that will be fairly easy to do. So let's just do that. Okay. Diode mode this mother again. .49. Okay, so that's not good. .49. Should be .7-ish. So let's find out where all these points go. CPU, the coil. So that's really it. And then the back side would just be that last resistor. So I guess maybe we could remove this resistor and then just rule that out. And then I think, I don't know, do we remove the coil as well? It's going to be interesting. I don't know. I'm not really sure if we should do that coil or not. And then if that is not good, then it's got to be the CPU, right? At that point. Looks like this thing is broken, actually. Or maybe I broke it, I don't know. I think I'm probably just going to break this thing, and hopefully it's okay. It's not picking one. Okay, so I'm just going to break this resistor. Maybe this, I don't know what happened to it. Maybe I broke it, I don't know. And then let's measure again. Okay, so let's measure it one more time. .48. I think that's good, right? I feel like that's a good reading now. .48. So that's a top one. Yeah, that's a good reading. So maybe that was it. Interesting. Bad resistor. Okay, so maybe hopefully this resistor is still on here. We can put it right back. Yes, it is. Okay, so let's put this one back before we get into trouble. Well, not trouble, but So I'm getting 0.49 on each side of these resistors, but on this resistor I'm getting 0.36. That's not good. And then on the other side of this is, so I don't think it's a resistor, unfortunately. So these I'm getting 0.49, which are good, and then but this one I'm getting 0.38, which the only other point is that it leads to is this in the CPU, and then this right here. So maybe we can take a look at the schematics. ISPUTSEL. ISPUTSEL. Is that it right there? So it'd be this line right here. And we've already taken out the resistor and the capacitor, and the problem remains. And then there's also this resistor right here that goes from the PP1V8 line. So let's see. Let's take this resistor back off again. So PP1V8, oops. So PP1V8 is supposed to be 0.36. And now it's 0.496. So when I remove that resistor, it gives me the right reading. Interesting. Maybe it was that resistor that was bad. Did I don't even know if I think I did replace that resistor though. So how does that make sense? How does that make sense? Yeah. Yeah. There you go. Alright, so now I'm getting the correct reading with both resistors off. So I guess maybe I'll just replace both resistors and hopefully everything will be okay. I guess I can also measure the resistance of this resistor as well and see what I get for that. This one right here. Hold on. So this resistor is not good. I don't think. I don't even know what the value is supposed to be. Well, it says 0 ohms, so let's take a look. Is it supposed to be 0 ohms? Let's see. It's supposed to be 0 ohms. It's supposed to be a 1K resistor, but it's 0. Well, that's not good. Okay, well that explains why that part doesn't work. Maybe I replaced it with the wrong one or something. I don't know. Anyways, let's get rid of this and let's get a 1K resistor. Do I even have? You know what? Let me see if I have a brand new one. I'll be back. Alright, so it looks like this is a 1K, and then the backside is a 0 ohm resistor, which is really just a wire. So I do have new ones, so that's what I'm going to replace it with, and hopefully I will get the same reading afterwards. I should get the same reading, yeah. Don't see why I wouldn't. So these things are dinky. I mean, they are small. Okay, so let's get a little dabble of flux here. And then let's see if we can flux this mother back. I don't know how I put a 0 ohm resistor here before. I mean, I took it from a donor board, so it doesn't make sense. Okay, so I think that's in business right there. Let's diode mode it real quick. Oh man. Let's see, diode mode. 0.36, which is right. 0.488, that is right. Okay. All right. Now we're gonna put the 0 ohm resistor on the back side, and then we're not gonna replace we're not gonna replace the capacitor right now. Okay. Okay, so that should be 0 ohmer. I mean, this is not going to affect anything right here. This is really just the jumper. So it's tweezers. So I guess let's. Where? Man, I always lose my tweezers. All right, so let's get a little bit of flux. Just really just a little sputter or whatever. It's not even the right tip. A little bitter tip right here. Okay, so let's see if we can just tint it just a little bit, and then I'm actually going to use my tweezers here. You got to hold your breath when you do these, man. These are the tiniest of the tiny. 01005, sir. Okay. Alright, let's diode mode it one more time, and if I'm getting 0.48, then I should be golden grams. 0.48, yes I am. Okay, so I'm not going to replace that capacitor right now, and now I'm gonna try it. Let me reassemble the phone here, or not reassemble, just assemble it so I can test it, and I'll do it live. Alright, I kind of cheated and I tested it myself live already, and I know the outcome, so it's going to be a good outcome. But as you can see, the camera works now. So I guess I don't know. I mean, that's really troubleshooting 101 right there. Is really with ZXW, it really makes it easier to do things, especially since they have diode mode readings. I mean, I guess this is kind of the equivalent of trying to fix something without schematics versus with schematics. Okay, so that's easier with schematics. Now, when you have ZXW tools with diode mode, it makes it a lot easier, because the alternative is to get a donor board, measure the diode mode values of the connector, of your known good board, and then diode moding the other, the bad one. And it's a time consuming thing. But before ZXW had diode mode readings, I mean that's kind of what we were doing. So I think ZXW is very valuable, essential for iPhone repair, and but the truth is, I guess we didn't really need it. We didn't really need ZXW tools to repair this. It would just take a lot longer to repair it. But so hopefully this kind of helps things. Let's see if the flash works. Okay, the flash works too. So, anyways, we're in business here. This guy will be happy, and I'm kind of glad I got this one. I spent a few hours on this actually, kind of just, and when I diode moded the connector the first time, I missed that actually, and then I went to the Facebook Microsoldering group, and somebody else had this problem, and I asked them what their problem was, and they said, diode mode reading was lower than normal for one of the pins. It was a different pin, but so I diode moded it again, and that's when I came up with this lower value that I saw. So I don't know what the ultimate problem was, but I replaced 2 resistors, so it was probably one of those 2 resistors that was bad. And just remember that shorted capacitors will show 0, or a shorted line, but bad resistors which are shorted doesn't necessarily show a shorted line. Okay, meaning if I were diode moding the pins on the connector, let's go to the ZXW tools. Now, if I were diode moding pins on the connector, and instead of 500 millivolts here, I'd get 0, then oh, that's probably a short capacitor, right? But if I get 0.37, then yeah, I mean, it's possible that it could be a resistor. So alright, well, I guess another one bites the dust. Well, it doesn't really bite the dust because we fixed it. But it is 2 o'clock on a Friday, and I don't know. I mean, I guess that's a successful day when you fix something like this. That's kind of odd. But maybe I'll just... Okay, alright, well, that's it. I'm out. Thanks for watching. Thanks for watching my videos on YouTube. I just want to talk to you about our online video course hosted at udemy.com. If you go to microsoldering.com and click on store, while it loads, click on Microsoldering the full curriculum. As you can see, we have discounted the price to $99.99, and if you click on this, you'll see that it contains 3.5 hours of online video instructions on how to get started in microsoldering, and we're also offering a certificate now. So after you complete the course, just email us at support@microsoldering.com, and we will send you a certificate, a signed certificate with your name on it, that you can display in your store if you want. Again, 3.5 hours of video instruction. We also have a forum now which you can post your questions, and we will answer it as quickly as possible. It is a free forum, no charge for it. The course is $99.99. Just click on this link, and that'll give you the discount, because if you go through udemy.com directly, it's going to be $149.99. So thanks for watching. If you want to learn how to do this stuff, then go buy this online course. Thanks, bye.